Hey guys, welcome back to the shop. Today we're going to talk about welding, specifically MIG welding, and the 2 secrets that you need to know to make you a better welder. Okay, forgive me on the clickbait stuff, but really there are only 2 key elements that you have to know to not only produce better welds, but to overall make you a better welder. I'm going to tell them to you right now. Number 1, cleanliness of the area and your weld material, so your wire or your filler rod or whatever. And number 2 is comfort. You cannot produce a good weld, well maybe you can, but most often you cannot produce a good weld if you're not comfortable. Let's see what all that stuff looks like in action over here. Hey guys, quick alibi here. This video is for the person who's never welded before or perhaps has a very small amount of welding experience and just wants to know more. This is not for the experienced welder. This is not for the structural welder. This isn't for the guy that's been welding for 100 years. So don't beat me up in the comments. This is very basic stuff. So if you're that guy that's high level experience, this video is not for you. All right guys, MIG welding. So for a MIG welder, like I said, this is going to be one of the most accessible types of welding that there is. There's a million of these machines out there. They're relatively affordable, and it's a good way to get into welding. So I think of a MIG welder kind of like a squirt gun. The gun here and a trigger. Now when you press the trigger, 2 things happens. It feeds the welding wire out of the end here, and it also feeds a shielding gas. In this instance, it's 2575, so CO2 and argon. And the purpose of the shielding gas is as you're melting the metal here at the business end, it shields that molten material with this gas. Because if it doesn't, the impurities in the oxygen and the air we breathe will ruin the weld. So that's the purpose of having it. So those are the things that happen when we push this button. It spits wire out, obviously electricity with it, and it flows the shielding gas to protect the weld. So welding is just electrical current, but we focus it on metal. So like any other current, there's 2 ends to it, right? A hot and a cold, or a business and a ground, for lack of a better term. So every welder is going to need to be grounded to something, and that's what this part is. This is just your ground. You clamp it onto your work surface, or perhaps you have a work table like this. A lot of the times when I'm working over here, I'll just ground it right to the table. So you got to be grounded as well as powered up to make any kind of connection to weld. All right guys, let's come in a little closer on the interface with this particular welder. Let me turn it on here and we'll see some numbers pop up. Now this particular welder has an option of being both a 220 and a 110 volt welder. Now the purpose of having the higher voltage is just to get it to burn hotter. You can penetrate thicker metal. Like when you're doing structural stuff on a vehicle, you may want to run 220 and get that higher heat so you can really penetrate that base metal a little bit better. Okay, so here we've got 2 numbers. You can see right here, this one says 16.2 and 7.3. This is your wire speed. On this particular one is your wire speed. And this one is going to be your voltage. Now, one of the things that you may hear some of the old timers say is when you're welding, you're looking for a specific sound. And that's true. You kind of want, I've heard it say, like the sound of a steady rain hitting like a steel roof, or the sound of bacon, that like sizzling sound. You want a very consistent sound. And you can get that by adjusting your wire speed and your voltage. Now what you need to know is that as you increase your voltage, you are going to have to increase your wire speed. There is a relationship between these 2, and there's kind of a small window that you can operate between the 2 of them. So if you have one way down and the other way up, that's not going to work. Think about it this way. If you've got a very high voltage setting, that electricity is going to go very fast because there's a lot of amps pushing it. Well, it's going to burn the wire really quickly. And if you don't have the wire to keep up with the amperage, you're going to have big misses or steps in your welding, and you're going to hear it's going to go pop, 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 because that wire is going to come out and then it's going to burn all the way back into the gun, and it's just going to keep going like that, pop, pop, pop. We'll take a look at what it actually looks like on a weld here in a minute. But these are the 2 main controls on any welder, any wire feed welder, is going to be your wire speed and your amperage. Okay guys, we're set up. We just have some test material here. Let's go back to that first key component we talked about, cleanliness. Remember, cleanliness and comfort. Those 2 things are going to make us a decent weld job here. So I just have some mild steel here, and what I did is I used the 80 grit on an angle grinder and knocked the mill scale off. You can weld through mill scale. I don't recommend it. It'll throw impurities in there. The purpose of the mill scale is to keep the bare steel from oxidizing, and what you want to do is you want to be able to penetrate that bare steel. So anyways, acetone for cleaner, and then blue shop towel, and get it nice and clean. So now we've got our clean and prepped weld material. Let's take a look at the tip of the weld gun and make sure that that it's clean as well. All right, let's look in here. I'm not sure if you can see this or not, but the inside of there is full of crap. We want to clean that out as best we can as to not impede the airflow of that shielding gas. So that is also something that comes into effect, or something that we need to concern ourselves with, is the cleanliness of this tip on the torch here to not impede any kind of gas flow. All right, before we jump into actually laying down bead here on our test piece, I want to talk about some technique. So say if we wanted to weld along this line right here. There's different techniques that we can do to pull a weld or to push a weld. I'm not going to get into the weeds on this stuff, but basically there's a couple different schools of thought. One is moving the torch in small C's. So you can go to a C and then bring it forward like this. And then what you get is that stack of, well, they call it stack of dimes if you're doing it right, that pattern behind the weld. Another thing I've seen guys do, and I've done myself, is circles. Circles works as well. And another one that works is just a push and pause. So if you push, pause, come back a little bit, push, pause, come back a little bit, push, pause, and come back a little bit. That's also a technique that'll work as well. One of the things we talked about earlier is how do we know if we've got the machine set right? And we talked about sound and the sound that the weld is going to create. That's an excellent way to tell if your machine is set up right. But most modern welders come with this chart, and even actually most older welders have it too. So what my recommendation is to get you really close, and then you can dial it in as you need it. Just refer to your chart. So if you don't have something like this, this is a wire gauge, and you just slip it over the material and it tells you what it is. Now this is 1/8 inch material, so I'll come down here to 1/8 inch. I've got the machine on to 220 or 240 volt. So this half would be 120, this half's 240. So it's 1/8 at 240, and I'm using 30 thousandths wire. So it's saying I should be set at 260 on wire speed at 18.5 for my volt. Make sure you're wearing your welding gloves and your welding helmet. All right, I've got the machine, or I've got the pieces tacked up, and those welds sounded really good. I'm not going to mess with that at all. What I'm going to do is I'm going to run a bead using the push and pause technique, and then we'll take a look at what it looks like. Okay, I just want to bring you in close and have a look at that. That looks real nice. Now what we're looking for when we're welding here, let me get something to point with. Now you'll hear things like if a weld is too hot or too cold. That's really simple. What we're looking for is just the edge of this weld to be burning into that base metal, or just kind of weeping into the base metal. It looks like the front part of my weld might be a little cold, but as the heat got into the base metal, it definitely did start to kind of weep into that base material. So I might turn it up a little bit to get a more initial bite, or just slow down my my movement here. But this, with the drag and pause technique, you can see how it just kind of stacks those beads all the way down. All right, now what I want to do is I want to jack this thing up. I talked earlier about high voltage, low power, or excuse me, high voltage, low feed rate. So what we're going to do is we're going to crank up the voltage, slow the wire way down. I want you to hear this. Okay, you could hear that, I'm sure. Okay, so the voltage was high and the feed rate of the wire was low. So you can see there's not a lot of wire deposited here. And you heard it too, that pop, 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 kind of like what I explained earlier. So what's happening is this wire is hitting our base metal and it's instantly just frying it. It's just cooking it, and the wire feed cannot keep up with it. So you can see, we actually got some good penetration on the back part of this weld here, but this weld was too hot for the amount of wire speed that we had. Okay, now we're going to do one more weld, and I'm going to crank up the speed and down the voltage. And you'll also hear what that sounds like. Okay, now with this one, I don't know if you could hear it, there was a ton of fluttering. And what was happening is that material, or the filler, was getting shoved into the base material, but it just didn't have the voltage to flow it. So if you look at it, it just kind of globbed up on itself. It sounded closer to this one than this one did, but look at that mess. If I had to pick, probably I'd go this way, if you're going to be on one end or the other of the spectrum. But again, that's our standard there. That's what we're shooting for. That is voltage and wire speed correct. Voltage and wire speed, let's see, what was that? That was voltage high, wire speed low, voltage low, wire speed high. All right, what I'm going to do now is I'll just turn around our test piece here, and I want to just do some other techniques here to show you what that looks like. And one of the things that you may run up across is welding up or down a seam. Now, what I like to do is I like to stay ahead of the weld. I don't want to get too far behind it, but you have two options. So you can push a weld, or you can pull your weld. Now, like I said, I like to stay ahead of it, and by that I mean I sort of like to push it. So I'll get my bead here and then come forward and then back up, forward and back up, and the whole time that bead is flowing in front of me. So we're going to get set up and give that a shot. Now you can see we've got much of the same pattern here going downhill. I slowed down. That's my fault. Like I said, I'm not a very good welder, but we slowed down a little bit, and that got our pool a little bit larger. But you can see welding vertical is no big deal. As long as while we've got it here, what I'm going to do is I'm going to try the C cup material, or the C pattern. So I'll start here and then kind of go back and forth, and we'll see what that looks like. Typically, I like to slow the wire speed down on that just a little bit, because I'm going back over the material so much. All right, so here's the C's. I'm not nuts about how it looks, but you can see it worked just fine. We got our weeping off into the base metal, so we know our settings are right, and it sounded fine. We got our little stack of dimes. I guess if dimes weren't round, that's what this would be. But you get the idea. All right, so next thing we're going to do is we're going to look at an outside edge here, welding an outside edge, and the differences that come with that. So let me clean this material real quick. I'm just going to get it tacked real quick, and then I'll explain some things about the particulars about these outside corners like this. Alright guys, one thing to consider when doing an outside corner is that these corners right here, anything with a sharp edge isn't going to take much heat to distort it. Basically that base metal will start going away and flowing into the weld a lot quicker than it would if you were just welding on flat or a butt joint or something like that. So anytime you see a sharp angle, a 90 or anything like that, or even edges of a weld, just be aware that those parts are going to go away a lot quicker than everything else. So when I do an outside corner like this, like for instance, if you're doing a step notch on a truck or something and you have a lot of outside corners, turn your voltage down a little bit from where it should be and just spend a little more time there. And that should still give you a strong enough weld and keep the integrity of the part as well. All right, now looking at this, you can see that material flowed a lot faster. There's still probably a little bit too much heat in this, and if I were to do this again, I would probably turn the heat down a little bit. You can see it did weep into our base metal. It was a little cold here, and yeah, it was a little cold, so maybe the wire speed needs to go down as well. But yeah, this, as you can see what I was talking about, is that base metal is going to go away really fast. If you look real close right here, you can see where it's starting to cut way down into that base metal. So for sharp corners like this, drop your voltage and apparently your wire speed down as well. Okay, I know we got off into techniques, and I didn't want to spend a lot of time in technique because honestly, you can see these different techniques, they all seem to work. Okay, your technique is going to be what your technique is, and the only thing that's going to develop that technique is you just burning material. You got to get in here and you have to weld. And then once you figure it out, it's gonna stay with you. Mine is the pull and pause. Yours might be something else. But the absolute, one of the absolute must, the two key components that we talked about is cleanliness and comfort. Now, in this position, I'm super comfortable. We talked about cleanliness, now comfort. You always wanna have at least 2 points of contact when you're welding. So I've got my elbow and my wrist and this hand right here, and my other elbow is like up into my hip. So when I'm down here and I'm running that bead, the only thing that's moving is right here. That's it. This wrist is moving, everything else is locked in, and you're just pulling that weld along. What you don't want is to be contorted in some odd position that it's uncomfortable to weld in. So say, for instance, if you had to weld way up here, maybe you need to bring in an extra piece to stabilize yourself. Maybe you need to bring in a block like this so you can bring your points of contact up so you're comfortable. And what I like to do is always do a dry run of where I'm going to pull that weld. In here, I mean, I know there's tons of room, but if you're under a car or back inside a wall or doing something, you're going to want to pull your arm or your hand or the torch through that range of motion to where that whole weld is, to make sure that you're going to be able to keep your comfort and your at least 2 points of contact while you pull that weld through. All right, guys, now like we talked about, I don't want to get too in the weeds with all this stuff. This is very basic stuff, but I think those are the two key components that are going to make you a better welder, is making sure everything is clean. MIG weld, you can get away with some dirtier stuff, but once you move into TIG welding, it has to be absolutely sanitary. So just keep that in mind. If you're building your bag of tools right now to become a better welder in the future, cleanliness and comfort. Those are two that you can absolutely not compromise on when you're looking to build your welding game. Guys, I hope you're able to take a little bit away from what we just did here. Again, keep in mind, this is not the end-all be-all on welding. This is just a quick introduction to talk to you about the machine and the very basics of welding, and what, in my opinion, are two very important criteria to becoming a better welder. What did we say they were? Number one, cleanliness. Number two, comfort. You gotta be comfortable, because if your arm's floating out in space, you're just not gonna get the weld. But anyways, guys, if you found value in this, I ask that you please just like, comment, and subscribe to the videos. And make sure you click that bell notification, because there's going to be a lot more how-to videos coming out. I think that those are the videos that I really enjoy doing. I know I've got some storyline videos with the cars and things of that nature, but I really enjoy teaching. I'm a teacher professionally, and I really enjoy this part of it. So please go ahead and jump on the boat here, like, comment, and subscribe, and we'll see you on the next one. I think we're going to talk about how to run a lathe next. All right, guys, we'll see you.